would like to invite my boss, CTO Hexagon AG, on the stage to give a keynote address. Thank you, Claudio.
Thank you. Hi, everyone. Pleasure to be here again with you. It's really a very interesting event. I could see some presentations, very insightful information. It's really, really great. Today, we are going to talk about autonomous connected ecosystems. This is the vision of Hexagon, and this is done through digital transformation. Digital transformation is basically, I will talk about, but just to keep in the context, is basically using new emerging digital enablers to provide automation. And the next level of automation is systems that are self-healing, that's adaptive systems that correct themselves, and then is what we call autonomous connected ecosystem. Sorry. Before I go to this, I want to talk a little bit about the reasons why I'm very excited to be here. Today is about India, right? So a part of India being number one fast-growing economy in the world, with some, the biggest, among the biggest economies, is the greenfield for foreign direct investment. That this is what empower, this is exactly what driving for faster growth. So not only is growing fast today, but the horizon is strong. And then there are other very important drivers for what we should be excited, right, in fact. I was last week, in fact, in a conference, AT&T conference for 5G. They are deploying the first 5G pilots, let's say. 5G will be another disruptor, right? Everybody knows. So we are talking about 10 gigabps, 10 milliseconds of latency. So it's almost real time, right? So we can push a lot of things to the cloud, and device will be more and more them. But in this event, there was speakers. Tony Blair was there, so a lot of important guys. And one consensus is that within the next years, there will be 3 giants in the world, right? US, China, and India. And these will be the countries that will drive the world. And Tony Blair was talking why they should not, UK should not leave Europe. Because alone, compared to India, US, and China, they are nothing. Maybe together with Europe, they can face a little bit the 3 big giants, among them India. But not only the growth, we can see also that there are commitment for modernization. And you will see in my presentation that modernization is really important to drive faster growth, to drive prosperity. So some of the initiatives that we see in India, smart cities, a clear roadmap, a clear budget dedicated to modernize cities, to interconnect the main workflows, process flows in a city, make cities more livable, more better quality of life, and better efficiency. Connectivity, outreach, broadband, for, networking, fiber optic networking being deployed, and so on and so forth. Manufacturing, very important manufacturing activities in India is also fundamental for the growth, for the future of the country. Infrastructure in many aspects, and that is important also for us. GIS-based initiative, geospatial deployment, cadastre, and other georeferenced solutions being deployed. Okay, let me go through this. Yeah. In order to put in the context of what I want to talk about, the autonomous connected ecosystems, I would like to talk a little bit about Hexagon. I know most of the audience are customers, so I would like to, for us that work in Hexagon, we know a lot of this, but I have to put also what we have in Hexagon, who Hexagon is, and our technology portfolio for this. It was already mentioned in some of the presentations today. We are 8 divisions. So geosystems, manufacturing intelligence, and geospatial PI, positioning intelligence, is more about sensors and hardware, so 70% hardware, 30% software in high level talking. The devices that are mainly for locate, position, navigate, and capture the real world. The other divisions, a part of mining and agriculture, is much more about end-to-end workflows, process flows, to make sense of the information and to stream information. So we have a lot of sensors for sure. Hexagon has a fantastic portfolio of sensors, and if you see in detail, the sensors are essentially related to capture the real world into the digital world, into the so-called digital twins. These are not mundane sensors. These are not single capture sensors. We are talking about really high-level sensors. Basically, Hexagon has no competitor in the same level on sensors and workflows, application workflows. Because of all our divisions, we are into many vertical sectors, very valuable, very important vertical sectors: manufacturing, construction, public safety, power and plant, mining, agriculture, infrastructure, and so on and so forth. So Hexagon plays important roles in vertical processes that can be really benefited by connected ecosystems, autonomous connected systems. That means if we can improve productivity, mining, in the processes in mining, agriculture, construction, infrastructure, public safety, we can see real value. So this is important. But because we design sensors, and because we have a strong footprint in very important vertical sectors, we have domain knowledge. And we see more and more that the new platforms for IoT, for digital transformation, are not horizontally agnostic, cannot be deployed in a holistic approach. This is why domain knowledge is a major differential in the future. It's not like CRMs, ERPs, PLMs, these collaborative platforms. IoT is all about vertical applications, domain knowledge. This is a very important point. Hexagon has a very long, I will not comment this, but a very comprehensive portfolio of technologies in the areas we address. But we can summarize all these technologies in a quadrupod, in four underpinning group of technologies, let's say. Always with the big vision of capture the physical world, so capture the real world, stream the real world into a digital twin, into the digital world, model, analyze, simulate to detect anomalies, deviations, and then with corrective actions, act on the real world in order to have more productivity, more quality, more security, and so on. So this is the concept. But with this concept, we can identify four groups of technologies where we are very, very strong. First, intelligence position. We can position anything, anywhere. High integrity GNSS, GPS kind of system to locate. High availability, high integrity systems. That means you can assure the position anywhere. Corrective systems, satellite correction, RTK, terrestrial collection, anti-jamming, anti-spoofing, and all this technology related to position and track objects, machines, vehicles, devices, etc. The second group of technologies is reality capture. As you have seen, all these sensors, we can capture reality, the high level. We can capture reality and model it. So we have a strong portfolio for reality capture. No, I don't see another company with this kind of portfolio of technologies. So bottom line, we can capture everything in real time. measure physical inputs, digital, as we call the digital realities. The third one is situational intelligence. We can provide intelligence and domain knowledge of what is going on in the context of the process. So we can contextualize what we captured and positioned. We can make sense of the information. Data is the new oil if you can make sense. If not, it's noise, right? Data without quality, data without actionability is nothing. So this is fundamental. This is why domain knowledge is fundamental to produce energy with the oil, right? We need the engine to move with the oil, right? And the fourth one, industrial design and planning. So for this, we can design, we can plan, schedule, dispatch, control, operate systems. That means from digital twins, from smart digital assets to operations. That means we have also a very comprehensive portfolio of technology for design and plan. These are the four legs, as we see, that will bring us to execute digital transformation into autonomous connected ecosystem. So our vision is really to have systems that are self-healing, systems that correct, adapt themselves to improve productivity. And this makes a lot of sense. You know, we have worked since the 70s. We have worked strongly in automation. Manufacturing is let's say, the lighthouse of manufacturing. But we see construction is lagging behind. Our performance, as we saw in the prior presentation here, construction runs still with low productivity. But now, with all these enablers, digital enablers that we have, that are more and more available, we have a very, very interesting path for better productivity. So this is the vision of Hexagon. Two, in order that we understand how we will execute, how we will walk the talk in digital transformation to ACE, to autonomous connected ecosystem, let's see a little bit Hexagon. I cannot go in all the details. Now, if you list the quantity of use case and technology that I could mention here, we don't have enough time. And frankly, I'm under extreme pressure here because the lunch is there, right? So there, I mean. And so I am in between. So let's see some of the technology. This is one foundational, very foundational technology, but it's so disruptive, it's so important for us. So all the laser and trackers, all our equipments that measure with laser, that is frankly speaking, we measure with many. We measure touching, we measure with laser, we measure with white light. There are many, but laser measurement is fundamental for us. And the base of this is measuring distance with laser, basically a pulse, right? The problem is that if you have fast measurement, you don't have accuracy. So there is a paradigm between accuracy and speed for measurement. We develop, and we have many patents on this, in the so-called WFD, Wave Frequency Digitizer. Basically, we compose two methods, right? The method of measuring by echo, right? Time of flight. You send a pulse and you wait, come back. You know the speed of light, and then you calculate. Picoseconds, very accurate devices. And the other is phase shift. You send many pulses and you measure the shift of phase. Two technologies, let's say, to simplify. We compose them in a very bright way, and we have this technology since, and this, frankly speaking, this is our differential to our main competitors. Another one is imaging. We call Project Andromeda. This is basically positioning with vision. As we human beings do. When we walk, I know that the stair is there, I know that there is a door there, and I position myself by vision. This is the way. But we are not doing this with the devices. Now we develop technology where you can position yourself with vision. And we have already prototyped this technology. The RTC 306 was launched in Vegas in June. So, and it will identify where it is, and we will stitch together point clouds. So post-processing, is reduced to a very, very important level. Another product that we launched, BLK 3D. We will see this in the demo zone. There will be demos there. You can see this in more details. But the vision, position, and navigation technology can be composed. Here you can see the person is moving, and the points are being registered, so the system knows that there is a corner, there is an edge, and as you move, it locates the next position in relation to the points that were registered in the prior position. So it's like we do, but here is measured, right? But we can fuse together this technology with the GPS, with GNSS, with inertial systems, and with SLAM navigation. SLAM stands for simultaneous location and mapping. This is basically, as you see here, a method that you measure and navigate at the same time. When we fuse this together, this is extremely disruptive, because we can enable applications that never were be possible. And one of the applications is our scan with backpack, that with this new technology, you can scan outside and inside. There are some applications, for example, narrow alleys in cities that we have a lot of alleys. Probably here in Hyderabad, you have examples like this. You have to go. How you scan if you don't have GPS signals? And GPS with inertial, is not precise enough for scanning. So now you can scan alleys, you can scan tunnels, and so on and so forth. That means you can scan from outdoors to indoor seamlessly. Very disruptive. Another foundational technology that we developed. Another one is to extract point clouds, to extract a lot of points from 2D images, from normal images. And with 2 cameras, you can triangulate and you can extract from 2D, 3D. This is a major disruption to normal technology. That means extracting mesh of point clouds from 2D, from many 2D images. Then you can do this with UAVs and mobile devices. Another one is classify the point cloud, the images, and the point clouds. Classify images, let's say, using artificial intelligence, using machine learning. So you can detect what is building, what is vegetation, what is terrain, automatically. The machine do this. Today, we still spend a lot of time doing this manually. Another one is identify objects and change automatically using machine learning. Disrupted, all these technologies are being productized as we speak now. So very, very important. We have also a platform for artificial intelligence. We use many different technologies of artificial intelligence, technology in machine learning, in deep learning, neural networks, and so on and so forth. And we call Simpala this platform. And it permits that we configure and deploy artificial intelligence solutions easier. There are many ways to look to how we identify use case for artificial intelligence. Here you see this diagram is interesting because you see in the bottom, customer intelligence, maybe I click all, customer intelligence, that you can understand how the customer use your equipment, telemetry, and so on and so forth. Planning and scheduling, you can optimize how you plan, how you schedule, how you dispatch. Pattern recognition, you can recognize anomalies from agriculture to public safety. People are lying on the floor in the train station, something is wrong, right? So you have to act. And construction, you can identify things changing in a construction site automatically. And the holy grail is process optimization. This is our ACE, automated, connected, autonomous connected ecosystem. So this is the platform, and we have many use cases for this platform. Going very fast for the benefit of time into our 4 major, let's say, group of capabilities of Hexagon. I would like just to give some videos here, starting with the reality capture. So we can say that we are the most, let's say, we have the most comprehensive tools to deploy capturing digital reality, capturing the real world. So we have scanners, terrestrial, UAVs deployed, airborne sensors, high altitude UAV, satellite. So we have a complete portfolio to capture the real world. But not only this, we have also a strong portfolio to make sense of what was captured. So data per se is not the end journey. You have to make sense of the data. So it's very important not only to process, but also to deploy, to visualize, and to make sense of the data. These tools permit you, for example, to the right left, to the right upper right, to see different view sheds of the image for public safety, for example, to understand what you can see from a perspective. You can see sites, you can superpose artificial augmented reality layers to as-built sites to see what changed, or CAD superposed to as-built. You can have, for example, traffic optimization using reality with theoretic simulated situation, and so on and so forth. To your right, lower right, you can see augmented reality. You can see a drone that is flying to an installation, and you can even have the view shed of the drone, what is happening with augmented reality. Okay. So our Smart Map 5D platform from Geospatial permit us to make sense of georeferenced workflows. So we can combine different data from different sensors, billions of points. And as you can see here, for example, you see here a train that is moving into a model of a point cloud, an image, and you can see the noise dissipation. And when the train goes into a tunnel, of course, the noise disappears. So this is one example that you superpose an image that you captured with a stream in real time. You could do this. A stream of information of trains and the dissipation that is basically simulated. This is another example where you can simulate, you can model and simulate the behavior of a vehicle. You can simulate different environments. For example, if you have snow, right? I want to test scenarios for autonomous driving. But then if it is snowing a lot, the behavior of the car will change. The sensors will behave different to capture position. So you have to simulate not only the car, but also the scenario. So we have tools where we simulate the car and the scenario. And we can use the simulated environments to train our machine learning or deep learning algorithms. That means the machine training the machine in different scenarios, zillions of different scenarios. We cannot do manually this. It's impossible, right? We just player for integrating different sensors for autonomous driving, but the technology is not only on autonomous driving. Also, we can use this autonomous platform to address other process flows. Autonomous driving is one application, right? So we have autonomous factory, autonomous cities, and process inside the cities, and so on and so forth. When we talk autonomous, we are not thinking only cars, right? Cars is very powerful because we are very inefficient. Maybe a car, the automotive industry is the industry creating the most inefficiency in the world, right? We have a 3,000 pounds car to drive us, that our weight is 150 pounds, more or less, right? And the power, what you put the gas in, you use 30% of the energy to move. The rest is lost. And we use the car 5% of the time of the car. It's totally nonsense, right? The automotive, we are used, so we don't realize this. but it's totally nonsense. This is why autonomous car is a priority, right? So, this is a complete platform. Hexagon, for example, I'm just giving some example to illustrate. Hexagon has a complete platform for autonomous car. From this modeling and simulation of a car, that is the Adams package of software, suite of software, to modeling environment and simulating environment. And this come from all the mapping technologies and is a feedback from autonomous, from driving a car and getting feedback to the car. And then we can sample environments from using AI tools. So this is a complete self-feeding platform. So it's really, really strong, and we have a lot of positive perspective on that. Last, I show here a video of in our mining division, where we make trucks in mining environment completely autonomous. That means you plan a route or a routine, and the routine is not only driving autonomous, but also loading and loading, or digging, or bulldozing, or whatever the let's say mobile asset has to do. So the truck drives, and for sure there are anti-collision systems that is needed in mining, because the size of the trucks normally are very big, And then we can, the truck, as in mining, the tracks are not fixed, because they move earth, right? So you cannot tell that the road is there. So the system has to map, to understand where it is the track and where is not, what was moved. So it scans, you have just seen, it scans in real time and drives through the path that is possible. Then loading and loading automatically, and so on and so forth. So this is a real project already. We are working with a Brazilian company, Vale, and with an Australian company, if I'm not wrong, Anglo-American, and we have this already working. For sure, driving a car in a city is much more dangerous, much more critical than you have a kid that can cross the road, so it's different. And last example, I'm not giving an example in public safety and in agriculture, and also in PP&M, in oil and gas, petrochemical, paper and cellulose, but there are infinite examples. We make an exercise to list use case for autonomous connected ecosystem. In a one-day section, we arrived to close 1,000 of use cases inside Hexagon, let's say, addressable applications. This is, for example, a cell. You can see to your left, a cell that is integrated machining and measuring. That means you can measure and you can adapt paths or adapt part program in real time. Ken Woodbine, in his keynote, in his presentation in the morning, MI has mentioned some of these. You could even feedback as built measurement to simulation tool to understand why the simulation tool has not predicted whatever should happen. That means you can close the loop in the real-time loop, but also in a T+, in a not real-time, to correct simulation algorithms from what you measure and compare. So it's very, very powerful. If you start thinking in the power that we have in our hands with autonomous connected systems, it's really, really, we can bring the productivity in another level. Here I show some other tools. We have white light. We call white light, but the laser is blue, in fact, right? So the light is blue, so it should be blue light. And then we have a lot, Hexagon has a lot of measuring tools, so I'm not going into details. We have also the notifications in the mobile part of this with the acquisition of Catavolt, now embedded in Exalt platform. You have a lot of possibility to orchestrate mobile applications. Okay, so let's go to the second part, this conclusion of the thing. So we see that we have a lot of trends. I will talk about the trends, technology trends very fast, but what I will talk much more is about the hurdles. Which are the hurdles? What is the difficulties to apply digital transformation and to make autonomous connected ecosystems? So let's see some trends and some drives, right? Because we are reading in the newspapers. Frankly speaking, the news nowadays, the news are technology news, most of the news. There are some political news, but if you see what is really relevant, people talk about Google, Apple, Tesla, etc., artificial intelligence, IoT. So there are a lot of drivers. And frankly speaking, this is not is so important any longer. The important is that you can use these enablers for disruption. So we are in a technology revolution, this is for sure. I guess nobody has doubt on this. There are so many disruptive flavors of digital transformation that I guess nobody has doubt. So the next step is drive digital transformation. So we have to understand that digital transformation is a path. And we see which have been the drivers, right? So we have availability of technology in a level that we never had before, right? So lower cost sensors, processing power, memory, bandwidth, infrastructure, now 5G, as I mentioned. Then data is growing at an incredible level. So 9% of the data was created in the last 2 years. You know, if you compare to all the human history, so it's nuts, it's crazy, right? So we let's say, capture something around 4.55 zettabytes per year of data. So it's a lot. But in 5 years, we will multiply by 10. And the other 5 years, we will multiply by 40. So it's a clear exponential growth of data captured, right? But if you think today, so 5 zettabytes per year, but one autonomous car, produce 1 petabyte. That means 1 zettabyte is 1 million petabytes. So one produce more or less 4 to 5 petabytes. That means 250,000 autonomous cars would produce today the same data that the rest of the world produces in all the other applications. So we are talking of things that we cannot imagine, right? So the other element is the following: the cycle of adoption of technology is growing like exponential too. You know, time to adapt a telephone was 75 years, and then time to adapt, for example, Twitter was 9 months. Pokemon Go is something very transitory, but it was 19 days, and then it was gone. But the adoption can be very, very fast. So, to understand, let's see, what is digital transformation then? That everybody has the same information. But digital transformation can come in many flavors. This could be enabling police officers with mobile devices, streaming data and video, voice, and make sense of the data. For example, I saw already applications, and we have this kind of application that if the policeman with a body camera start to run, the camera will stream and video analytics will start to identify stuff. Can be from the heartbeat or can be just GPS oriented. So this is digital transformation. Or could be enabling process, interoperating process in a smart factory, city process. Can you imagine that today in New York or in London, the planning of dispatch of police ambulance is not aligned with event? For example, if there is a major event, the dispatching doesn't take this in consideration. So it's totally nonsense. Just interoperating using digital technology, different processes in a factory, in a city, would be very, very, very powerful. So bottom line, what is digital transformation? Digital transformation is simply the use of digital enablers to improve processes, to make processes more productive. Very simple definition. But which are the hurdles of, with digital transformation we want to reach, we want to enable autonomous connected. But which are the hurdles of digital transformation? it's interesting that most of the hurdles in human history of technology, most of the hurdles are related to things that we don't see. Things that are beyond the line of water in an iceberg analogy. So, and normally because we are working hard. When you want to deliver the roadmap next month, next quarter, you don't have time even to helicopter perspective of things. So, the first hurdle that I would mention is data generation. We generate data in a crazy speed, but we don't use the data in the same speed. Because why? Why you cannot process and create insights from the data in the same speed that we capture the data? Because we, human beings, we are in the loop. Systems are not autonomous. Now, how we can accelerate it? We can accelerate this with digital enablers. Machine learning, communication, integration, artificial intelligence techniques, orchestration from edge, premises, cloud, and edge computing, edge analytics. You capture the insight at the edge. You don't have to bring all the information, even with 5G. It would not make sense to bring everything to the cloud. You should data mine at the edge. Bottom line, machine to machine, human cannot be in the loop. Human has to receive insights in a mobile way. So this is another hurdle, the hurdle that we are in the loop. The systems are not autonomous. Going back to how I am in the time. Okay. Going back to our vision, to Hexagon vision, we want to capture, stream, model, analyze in the digital world, corrective actions, act back for performance. The second hurdle is that technology that we have are fragmented. The technology portfolio that the enablers are all fragmented, they are not integrated. In order to have autonomous systems, we have to abstract the integration complexity. The same is very, very in sync to what the prior presenter here mentioned. All the user interface, simple user interface, keep it simple, scalable, etc., goes through the seamless native integration of enablers of digital transformation. That means simply connecting. A lot of people say IoT is interconnectivity, and 5G will improve a lot IoT because it will be kind of hyper connectivity. This does make sense. Connecting A to B is not solving the problem. You have to make autonomous systems. Connect is just one enabler of the thing. That means converging is what really is important. Converging the real world to the digital world. Convergence will enable digital transformation. That means data and process composition, interoperating workflows, processes, and data sets. We call this the process of interoperability of systems, capturing the real world into digital realities, the enabler for autonomous connected ecosystems. There is a quote of a guy from maybe 50 years ago, or maybe 30 years ago, that the guy has already this vision, right? Autonomy can only be achieved by converging digital and real world. So, to close this section, we know the world is complex. The process, all the processes in all the industries are very complex. We know the portfolio of technology that we have is complex. So the only way to abstract complexity from the real world to creating digital tools is through a platform that can abstract this complexity. The first step is modernization. And I mentioned India is modernizing because I want to correlate with this. We have to modernize. What means modernize? Start using new technologies. This is the first step. And the second step is a radical new approach to accelerate through a platform that can put together all these enablers in a seamless, integrated way. So we call, in our case, in the case of Hexagon, we call this Exalt. Exalt is a robust digital transformation platform that offers end-to-end edge, cloud integration, back-end integration, front-end integration, IoT, etc., etc. Let me go back. The main capabilities are enterprise integration, mainly back-end integration, edge, cloud, computing, and connectivity, orchestration, premises, edge, cloud, network, mobile web visualization, and AI techniques permeating across all the things. That means AI at the edge, composed, orchestrated with AI at the network, at the cloud, on premises. And the architecture of the system has to encompass this. When you architect a system, you cannot think only in software. You have to think from the hardware to the back end, because there will be distributed architectural systems. This is the next frontier, in my opinion. That when you design architecture, you can think that you will have to push a kernel of your algorithms to the edge. But this is another discussion. So what we are doing with Exalt, we are deploying Exalt to all the divisions. Oops, sorry. Again. So we want to in the roadmap of all divisions. This will go different. It's not one speed. Depends on the division. This will be faster. We will face different hurdles in the divisions. Some divisions are already implementing this, already productizing this, or productizing this. Our division will experience. There will be some features that we don't have, and we will work to do this, and so on and so forth. But this is a process what Hexagon is very, very advanced compared to our competitors. We will have a section now after lunch. We have a section of Exalt, so we will see all the capabilities that we have already and others that we are bringing to the game. One of them, for example, is mesh API systems. Is a network. The network of APIs is a new concept, very, very disruptive tool that we will incorporate to Exalt, and so on and so forth. Many examples. I will give just one with more details for the benefit of time. This is an example that's already productized. It's in MI, in the metrology part of MI, where you have edge functionalities in the bottom of the image, edge functionalities, edge clients in all the machines, capturing data, but they can receive also. You can push a complete workflow to the edge. That means I can change the behavior of the machine on the fly, real time, according to a logics or machine learning process. But in this case, you can grab information, integrate with backend or backend systems like ERPs, PLMs, etc., push to the cloud what is relevant, create notifications, and also at the same time have algorithms that compare the systems and balance workloads or change the behavior of the systems depending on what you measure. For example, if you have a stamping line that do many things to a part, you could measure in each part and see what's happened and change the next stage according to the behavior to the prior stage. So this is something that we can do right now as we speak. So this can be passive, but can be active too. This is an example productized already. We can do the same for factories. Factories have many workflows that could be interoperated and composed at the same time. This is another use case that is already productizing mining, is machine health. They call machine health, but it's a predictive maintenance. We have at the edge, that means in the mobile asset, we have the onboard computer. We collect information from the onboard computer. We integrate to the back-end processes, and do the predictor. We have predicted algorithms, and we extract the anomalies of what happened, and we take actions. For example, actions can be predicted maintenance services. We can serve the part before the part fails, so we prevent the failure, the stoppage of the truck, or we can not do something, that there is, for example, a preventive action, and we don't do because it's not needed. So anyway, we we improve usage of the assets. For mining, where one truck can cost $3–4 million, this is very significant. Job site enablement, that means the famous smart remote workforce or workman. That means we can push to a tablet a lot of process that can be implemented for a mobile worker. This is another thing that we are prototyping too. This is a very powerful example. We are implementing this in Geosystems. We are putting an edge client. We are deploying an edge client in each product, each device, and then we can collect information so we can understand how the device behaviors, not only how the customer use, but also how the device is behaving. We can collect all the information, we can understand the customer, it's called customer intelligence. We can understand the device, and we can change the design or the next releases of the device according to the behavior, so we can optimize. This is the famous virtual cycles from the guy from Baidu, the CTO of Baidu. If you sell a lot of products, you have a lot of customers, you have a lot of usage, you data mine, you machine learning, you have better products, then you sell more, you have more customers, you have better products, you machine learning more, so it's a virtual cycle, right? And this is very dangerous because it brings monopoly, or kind of monopoly, right? But this is something that we are implementing. But at the same time, you could have also a machine learning algorithm that understand how the products are behaving. You could push a change in the workflows to adapt. So India started already its digital transformation journey. We can see this in many Indian customers, and I challenge you guys. So what about you? We have to start thinking. And everything starts from the use case. Where we can use the enablers, where you can use our traditional core technologies with the digital, with Exalt or the digital technology, the digital enablers to improve, to go in the direction of autonomous connected systems. And frankly, it's not a system of systems. We can find one process that can be make autonomous, and then we improve that process. Then we improve the next process, and then also. Never, the things doesn't come in one shift. We have to start. Normally being bold and starting doing something with the direction of autonomous connected systems. So thank you for your time. Namaste, and let's have lunch now. Thank you very much.